Okay, guys, as we're looking at the study guide for concept unit 4B, we're going to start with concept 21. We always want to make sure and check the domains of the original functions that we're looking at if we're trying to just talk about domains at the end too. Because remember, if there's a restriction that starts at the beginning, it's going to carry through. So this first one, 4x minus 1, has no restriction because there's no fraction. So the domain is all real numbers. And same with g, there's no fraction, so your domain is all real numbers. All right, and so when they ask us to do f of g of x, or f plus g of x, remember that that's f of x plus g of x. And you're going to just substitute the equations in and combine like terms. So we have 4x minus 1 plus negative 3x squared plus 5x. And as you combine like terms there, you get f of x plus g of x equals negative 3x squared plus 9x minus 1. And again, there's no fraction, so your domain is all real numbers. F minus g of x, again, I prefer to look at it as f of x minus g of x. The biggest deal here is to make sure that you distribute your negative through into the g of x function. So we've got 4x minus 1 minus the whole function of g of x, which is negative 3x squared plus 5x. When you distribute that negative through, you end up with 4x minus 1 plus 3x squared minus 5x. And combine like terms, we end up with f of x minus g of x equal to 3x squared minus x minus 1. And there's no fraction, so our domain is all real numbers. On 3 and 4, we have a new definition for f of x and g of x. Our f of x function is, again, linear with no fraction and no variable in the denominator, so your domain is all real numbers. Our g of x, however, is a rational function with x in the denominator. So we're going to state that, take our denominator, which is x, and state that it can't equal 0. There's nothing to solve, so that's your domain. Just remember that if you have a restriction in one of the original functions, it carries through to any newly created function, even if it doesn't look like it would appear in it. So when we have f of x over g of x, remember you're going to put the f of x function on top, which is 7 minus x, and it is divided by 1 over x. Okay, and we looked at in the notes and in class about how to change it so that it says 7 minus x divided by 1 over x. And that's where our keep, change, flip came in. So we're going to keep the original function the same, 7 minus x, and then change our division to multiplication, and then we flip the 1 over x to just x. When we distribute, we end up with 7x minus x squared. And that is our function. When you just look at that final answer, it doesn't look like there's a restriction, but this restriction from up here carries through, so our domain is still all real numbers, not 0, or x not 0, however you'd like to write it. So on number 4, we're going to, it's the same as g of x minus f of x. We're going to put our g of x function in front, which is 1 over x. And we're subtracting the whole function, 7 minus x. So when you do that, you've got 1 over x. We have to distribute this negative through, and it just becomes negative 7 plus x. And as far as the test goes, you can leave it like this, and that is your g of x minus f of x is what we just found. And our domain carries that it's all real numbers, not 0. The last thing that we're going to look at in concept 21 is composition of functions. And again, we're going to check our original functions to make sure that there's no restrictions on the domain. There's no restriction on F. It's all real numbers because there's no fraction, and same with G. Okay, so remember that F, this number 5, the way it's written is read F composite G of X, which we can rewrite as F of G of X. Okay, which means we're going to take the G of X function, which is negative X minus 2, and it's going to get plugged into the F function. So we're going to go to the F function up top up here, and then usually it's X. In place of that X, this whole thing is going to go in. So we're going to end up with 8 times negative X minus 2 minus 1, and then we're just going to distribute and combine like terms. And what we just found there was F of G of X. On 6, they're asking you to do G composite F of X, which is telling you order matters. Remember, this time we're going to plug the F of X function into the X for G. So the F of X function is 8x minus 1. So this time, in place of this x, that whole x is going to go in. So it's negative, and then we're plugging all of that in for x, so 8x minus 1, then minus 2, and we just need to distribute the negative, become 8x minus 1, or plus 1, minus 2, so we get negative 8x minus 1. Is G of F of X. And again, there's no restriction on either of these domains. I forgot to do that. Domain over here is all real numbers because there's no fraction, and same with over here. No fractions. Okay, on 5 and 6, they were asking us to plug in full functions, and we got new function answers. On 7 and 8, they're asking us to plug in numbers, and we're going to get a numerical answer. So this is more like double substitution, and if you do F of G of 3, okay, we're going to find G of 3 first, and G of 3 will go to the G function and plug it in, so that's negative 3 squared plus 3. That negative is not being squared, so that stays a negative, and 3 squared is 9 plus 3, and we end up with negative 6. That is our G of 3. So this whole thing is going to go into the F function because that's what G of 3 is. So we're going to do F of negative 6 and plug negative 6 in, so we get 4 times negative 6 plus 1, which is negative 24 plus 1, and we end up getting negative 23. And what we just found there is F of G of 3. Since we got a numerical answer, we're not going to state the domain because we don't have a function. On number 8 over here, we're doing F of 3 minus G of 3. So we're going to find each of those. F of 3, if we go ahead and find that one, F of 3, we end up with 4 times 3 plus 1, so we end up with 12 plus 1, which is 13. That is F of 3. And then if you remember over here, we already found G of 3. We don't have to find it again. So F of 3 minus G of 3. Oops. F of 3 minus G of 3 is going to equal 13 minus negative 6, which is equal to 19. For concept 22, we're looking to find inverses of function. Remember, there are 4 steps. The very first step is you're going to change your f of x to a y. This is the exact same function still, just in equation form instead of function form. Okay, then you're going to switch the x and y. And then we're going to isolate the y. So we're going to move the 1 over. And to get rid of a fraction, remember you can multiply both sides by the reciprocal. So it'd be -3/2. And if we distribute that, our y is going to end up being by itself. So y equals, if we distribute this, we end up with -3/2 x plus 3/2. And then we're going to tell everybody and their brother that what we just found is the inverse. So we're going to call it f inverse of x and then just state our equation. Number 10, same thing. We're going to switch our f of x to y. Switch the x and y. And now we're going to solve for y, which means we're going to square root both sides of the equation. Get plus or minus square root of x equals y minus 1. Move our 1 over. We get 1 plus or minus the square root of x equals y. And tell everybody that what you just found was the inverse. So f inverse of x equals 1 plus or minus the square root of x. On this one, again, we start with step 1 is switch f of x to y. Switch the x and y. Solve for y. So in this case, we're going to square both sides. And add the 3 over. And then tell everybody that we just found the inverse. Number 12, same 4 steps. Switch f of x to y. Swap your variables. And solve for y. So we're going to subtract our 8. We have to get rid of the negative and before we can square root both sides, so we can either multiply or divide both sides by -1. What it ends up doing is just changing all the signs. And then we're going to take the square root of both sides. So it's plus and minus. The square root of -x plus 8 is equal to y. And then we tell everybody that that is the inverse of our original function. Lastly, down here, find out if the pairs of functions are inverses of each other or not. Remember, to do that, you're going to do composition of functions. And when you do f of g of x and g of f of x, they both have to equal x for them to be inverses. If you solve one and it doesn't work, then you don't have to solve the other. But if you get x for one, you have to check the other direction too. Oops. So we're going to do f of g of x first. I'm going to plug in the g of x, which is x squared minus 1 in square root of, and instead of x plus 1, we're going to get x squared minus 1 plus 1. The minus 1 plus 1 cancels, and we get square root of x squared, which is just x, so that one checks. And then we need to check g of f of x. So when we do g of f of x, so we're going to have g of this whole function, square root of x plus 1. And show that we get, let's see, we're going to have x squared, square root of x plus 1 squared minus 1. The square root cancels the square, and we get x plus 1 minus 1, which is just x. So yes, they are inverses. Okay, same with the next one. We're going to do f of g of x which is f of 3x plus 6, which means it's 1/3 times 3x plus 6 plus 2. If we distribute this, we get x plus 2, and then we have the other plus 2, which gives us x plus 4. So no, they are not inverses. If one of them doesn't work and equal x, then they're not, neither of them are going to work. So the last thing that we talk about in this unit is solving inverses when the variables are defined. Remember, if the variables are defined, you're not going to switch the variables, you're just going to isolate the other one. So we're just going to take v equals 1.34 square root of L, and we're going to isolate this L, which means we have to divide both sides by 1.34. So we get v over 1.34 equals the square root of L, and then we're going to square both sides and make sure you square the whole thing. So L is going to equal v over 1.34 squared. Okay, so when they tell you the maximum speed, and they determine maximum speed as v in knots. So for part B, all we have to do is plug in 7.5 for v. And when you plug that into your calculator, you get L equals 31.3 feet. All right. And the last one they have down here, they're asking us to solve and find the inverse. So this time we're going to isolate this W. So we have L equals 0.5 W plus 3. If we're isolating that W, we're going to subtract 3 from both sides. Okay, 0.5 W means half of W. And so to get rid of half of W, you can either divide both sides by 0.5, but I don't like putting decimals on the bottom. So I'm going to multiply both sides by 2, because that's the reciprocal of 0.1/2 is 2. So half times 2 gives us just a W over here. If we distribute this, we get 2L minus 6. So that's our inverse. W equals 2L minus 6. And when they ask us to plug in down here, they give us the length, which is, so it'd be 5.5 minus 6. And W is going to equal 2 times 5.5 is 11 minus 6. So we get W equals 5 pounds.